let's go. Good morning, good afternoon, good evening, good dawn, good whatever you find yourself. It is Tuesday right about now, Accra, Ghana, where I am, 8:36 p.m. Um, Welcome wherever you're joining us. My name is Samuel Adranyi, yours truly, bringing you another episode of IoT Tuesday, the only show on the planet. Yes, I mean it, the only show on the planet that seeks to, demystify IoT to the barest minimum. Welcome to Prime IoT for joining us, the first person in. I'm going to do something for the next couple of episodes. I want to see my consistent, members who join live and give feedback and comment. I'll be doing a giveaway. I'll give out one of my dev kits. As you can see behind me, there are like lots of stuff in those boxes. I'll be giving away. It's part of a plan for next year, which is a couple of weeks away. So I want to build my followership, people that are really onto it. You can make suggestions on what you want to see us build, and also less experiment is coming. Anyway, before I get ahead of myself, welcome to the IoT Tuesday show. If this is your first time, this is the only show that demystifies IoT to, to the layman, to the simplest of forms. Well, in today's episode, we're going to take a detour away from the Vision Dev Kit because I'll explain later when we come back into unboxing one of the dev kits I've had, for some time now. And like I mentioned, I want to unbox all the dev kits I have for 2021, so that when we get into 2022, it's all going to be new stuff. So when we come back from our intro, we'll be getting into unboxing that. So before we get into it, here's our intro. Yes, and we are back. If you're just joining us, we just got started with IoT Tuesday. Yours truly, Samuel Adranyi, bringing you all the good stuff when it comes to IoT. Anyway, so like I was saying, we're taking a detour from this for now because it's still giving me a lot of problems. Like I've reset it to factory. It's not able to pick the edge cases. I'm still doing some background stuff with my friends from Microsoft and other places, and Altec. So I'll give you an update on that when it's happening. We'll switch back to another episode because next year we are focusing on AI and IoT and everyday life. So pretty much it'll come back, but once we figure that out. So to do that, I'm going to jump into unboxing one of the dev kits. We're going to, break it apart and, when I say break it up, like open it up, set it up. Now, the good thing is that this dev kit we're going to unbox today also has some kind of ability to do AI. So pretty much set with the goals we've set for ourselves. But before we get into it, as you know, a couple of things I put out there before we get started. And in today's episode, I'm actually excited about two things. Two. Now, gone were the days when if you were using Arduino, pretty much it was quite difficult to get your Arduino to communicate with some cloud of a form. So either you needed to have a device that was cloud ready, right? Or you had to go through a lot of hoops to get it, to talk to some cloud provider. Well, worry no more, because Microsoft and the IoT team has released a set of IoT libraries for Arduino. Isn't that exciting? I'm not getting anything. Where's our applause? Yes, that is exciting. It Yes, and it's also awesome. So let me quickly share the URL with you guys, and then pretty much we can check that out. So it's set of libraries that allows you to now connect all your Arduino devices to the Azure IoT suite or set of services, or Azure IoT, so to speak. So you know bare minimum, easy, straightforward libraries you can add, just like you open your Arduino IDE and add libraries. So one thing we're going to do is that we will spend some time in the coming episode to see how easy it is. We'll put up an Arduino board, set that up. Maybe we can do that next week. Yeah, let's do that next week before the year ends. Let's see how we can use this library, to get stuff going in Azure. So the second thing, if you are interested, hold on. I said I was going to share that link. Um, yeah, so actually, let's open this up. Let's open this up. And if you're joining us, thank you for joining. Welcome to the show. Please, 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 Operation 1000 is still ongoing. I'm hoping and wishing that before the year ends, I would clock or reach the 1000 mark. There are a lot of limitations now. I can't do some live streams some ways because I don't have 1,000 subscribers. So if you're watching me, please, 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 and it's your first time and you like the content, please register, sorry, subscribe to the channel, and then hey, let me know what you think, comments, suggestions, all that stuff. Let me know so that we can pretty much have some fun. So I'm going to throw in the first link and share that with you, and that is the the Azure IoT library for Arduino. So it should be on your screens right about now. So if you go to this URL, you should be able to see a link to that, and it includes RTOS as well, and general middleware for RTOS and stuff like that. So cool stuff. Go there, get the libraries. Now you're able to connect your basic Arduino devices to the Azure IoT services. So with that out of the way, what is the second URL that I want to share? Actually, I can actually share how that looks like for now. So we can get. So if you go to the link I just Hey, ho, this is all the way from Gabon. Afi is on the show. Welcome to the show, Afi. Thanks for joining all the way from Gabon. Wow, we're getting lots of love today on the show. Awesome, awesome. Good to see you. Hope you're having fun on the show. Let me know if you have any questions about what we're doing, the show, general questions about IoT, and I'll be very much glad to answer these questions. So if you go to the first link, this is the Arduino library for IoT. Go download it. You have some, like I mentioned, some platform have out of the box support like ESP32, 8266, and the rest. But then, this would allow you to embed pretty much embed Azure IoT connectivity into your devices, pretty much. So, with that said, let's go to the next URL I want to share with you, which is the Microsoft IoT blog. Yeah, that's it. So if you are a lover of IoT and you're interested and you want to be updated, with what's happening in the Microsoft ecosystem when it comes to IoT, this is the place for you. So go to MS IoT, which is MicrosoftIoTblog.com, which is your one-stop, place for all the news regarding, IoT news from Microsoft and all the good stuff, projects, um, things people are working on, updates, all the cool stuff. I mean, we can actually take a look at that. So if you go there right now, you can see just what I shared. The Arduino library storage there, Azure Percept, connectivity with 5G, Edge, and AI. All cool stuff. A lot of stuff going on. Projects people are working on. All the interesting things you want to know. Go check out. Go check that out at the msiotblog.com. Well, awesome. With that out of the way, right? With that out of the way, what are we going to do? What are we going to do? Yeah, so like I was saying, today we are going to be unboxing and getting started with the Corel Dev Kit. So let's switch to the bench. And again, if you have any questions, please put it in the chat. I'll try as much as possible to answer you. Thank you for joining the show. And please, 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 like I said right here, go to the YouTube channel, subscribe to the channel, yeah, let's do it. Let's get to 1K sub. Yes, really, I really appreciate if I can get to 1K before the year ends. That's actually is going to help me do a lot more crazy stuff. Before I was going to get ahead of myself, next day we're going to start Let's Experiment. And what Let's Experiment is going to be a fusion between pretty much all the technologies I use. So from mixed reality, from drones to IoT to other, putting all of them to create projects or solutions, or kind of like experiment on how to use all of it. Now that's going to be involving. It's also going to be expensive and stuff like that. If you want to see more of this, please let me know what you think in the comment section. And please bring your suggestions, projects you think we need to build. Don't worry, we have everything we need to build a project from beginning to the end. You can see there's a Snapmaker 3-in-1 behind me. So pretty much from CNC laser, 3D printing, we can pretty much do anything we want to do. We can build technically anything we want to build on the shows we have. So keep the suggestions coming and we'll do that. Wow, so let's go to our bench. This here is the Corel Dev Board. Let's see. I believe I have, um, let's see. Did we tweak this? Anyway, so this here is a Corel Dev Board, and I've had this Dev Board for a while now, but I think it's just time to unbox it. So I put this little teaser here. This is a chassis for, um, um, one of these obstacle avoidance vehicles, which we'll be building. If you have kids from, ranging from the ages of 6 all the way to like even 17, who are interested in robotics, IoT, and stuff, we're coming up with some boot camps for them to build these things. And actually, the interesting thing is that what we're going to do is that they are going to, laser cut or CNC cut out all these chassis and build themselves from scratch. So if you have someone interested in doing that, reach out to me so we can get your kids onto the list. Well, this was just a teaser. Let's put that aside. And today, this is what we are going to unbox. So we're going to unbox it. We're going to set it up and do it. Now, if you look at it, it says that it is a single board computer with edge TPU. So pretty much, uh, we have a board that is going to allow us to do some kind of AI, right? So let's get into it. So this pretty much, let's see, let's get it there. So behind it, let's see what it includes. So in this, I'm trying to make this so you can see this. It includes the edge TPU. This, I think I need to change my camera. I need to do some investment in this one. So yeah, we have the TPU Edge board. So it focuses well when it sees my hand somewhere in the view. Stay here. Focus, focus. All right, there we go. So it includes the TPU, the 5 volt stuff like that. So single board compute with HTCPU system on module. All right, let's get into it. So my handy partner. Let's open this up. Let's see what's in it. So we have a very nice get started at g.co/coral. Um, so pretty much the edge, just oh, so yeah, I forgot to mention. So this is one of the dev kits from Google. So it's Google's IoT stuff. Okay, so this is how it looks like. Dimension schematics for it. It has HDMI. Awesome. We should be able to do some connection today. So HDMI, USB Type C, great. USB Type C cable. I mean, so for power and for data, headphones, 4-pin stereo Ethernet, USB A, and we have 40 GP IOP, almost just like the Raspberry Pi. Um, I think what I would do is that we'll move this and I'll try to compare it with a NVIDIA Jetson Nano so we can see the two differences. So yeah, so we have let me put this somewhere here so I don't hit myself. So we have this, and then we have the board itself. Pretty much, that's just it. That that that's just it. I mean, it's just a see. That's it. I didn't miss anything, right? All right. Well, it's good that we already have some of these connectivities there. So let's do this. Let's see. Pa, pa, pa. Let's throw this here and let's open this up. And I hope this. Okay, so there we go. This is it. Let's see if I can bring my tripod down a bit so that we can get a lot more closer. We can get a lot more closer to it from here. Let me just get rid of this. Sorry. And yep, lock this in place. All right. And let's get down. Awesome. There we go. So this is the kit. pretty much, let me take it out of the, so we can see the dimensions. Quite, it has a very, oh, look at that. So there is the Google right there. And this, yeah, this is the first time I'm opening this up. So we could have, I don't see, well, I think I see an SD slot. I could be wrong, but here, there's the HDMI. There is the, okay, so there's the power and there's the data and there's the Ethernet. So we can connect to the internet. There's USB here. And yeah, and then the 40 input IP. So I'm tempted to say with this input output pins, if I have, let's say, the T cobbler for Raspberry Pi, I should be able to. This is much smaller compared to the NVIDIA Jetson Nano. It's of a very small form factor. I have that. I can show you. I think I should do that right now. Let me bring that up so we can do some very quick comparison. So this here is the NVIDIA Jetson Nano. All right, this side looks quite maybe bulky and bigger. Let me just quickly move this. It's quite straightforward and simple for me to do that. So let's do this. Okay, so if you look here side by side, definitely the NVIDIA is way. So let me put it on it for you to see this. So it's quite big, right? Um, so form factor wise, NVIDIA is bigger than it, but I see more USB connections on the NVIDIA to video outputs, right, compared to this one. But anyway, the focus of today's is the Corel. So let's keep it let's keep it that way. Let's keep it that way. Look at me. My singing singing stuff is coming. Okay, anyway, so this is it. So let's look at the, yep, let's go back to the manual. So per the manual, um, it says, yeah, I was right. It's the micro SD slot. Okay, and there's also the opportunity to connect cameras and display. All right. So per the dev board, we're supposed to get started. Go to g.code/Corel. All right. So let's do that. Um, let's do this. Let's do that. Let's go here and then let's go to g.co/Corel. We are there. Let's see what we have. Uh-oh, dynamic link not found. Interesting. This is interesting. So first thing, dynamic link not found. Short URL g.co/Corel. Oh, hold on. It's actually Corel. See, when you start working with, when you've been using Corel Draw for God knows how long, you start seeing everything else Corel. Corel. Anyway, the link should be there. There you go. So that is it. Corel. Ah, build beneficial and privacy, preserving AI. Yeah. Efficient, balanced power. Pretty much all this. We just want to get started. Okay, so this is what we have. Flexible enough for startups and large-scale enterprise. Okay, In interesting. So solutions for on-device intelligence. So pretty much it's telling us that we can build different solutions with it. Object detection, pose estimation, image segmentation, key phrase detection. So pretty much voice. Okay, smart cities, smart buildings, manufacturing, helping people getting around. Okay, yeah, pretty much. Yeah, we're okay with that. We want to, what are we looking for? Examples took us there. Let's look at docs and tools. I think that's what. So these are examples. So image recognition, object tracking with video. With video might require us to connect a webcam or video camera to it. We just want to keep it to the barest minimum. Semantic segmentation. Okay, wow, that's interesting. That's a lot of cool stuff that can be done with it. So one of the things I want to try with some of these things is building kind of like your own voice assistant. So something like Alexa or Google Assistant. What you can do is that you can build some of these things and give commands and will translate your, so we'll do speech to text and you can transfer that into something like your own home automation system. Interesting. Imagine putting this into from the text to home assistant into, let's say, controlling your lights. I think we can try that. Pipeline image classification, basic image classification, object detection, and look at that. So there are examples here. Sound categorization with okay, interesting. So here keyboard, interesting. All right. Um, we are not. Well, yeah, we'll do this at some point. But hey, let's get it started. Now that we've unboxed it, so I think we should go to docs and tools. The instructions and the manual just simply said we should get started there. Pretty much follow the instructions. And that's just all it said. We don't have anything specific in there. So let's go ahead. Okay, so if you look at this, we have the dev board. Dev board meaning so ours I think is the dev board. Set up your device. So let's look at this. So there you go here. So we're going to start from uh, we're going to start from here, right? From this particular section, and I was going to use a dev board. So let's get right into it. So dev board, let's click that, and it says, all right. So this is it. I knew it. I kind of had, I had this feeling that it was going to run on Linux. So as you can see, the setup requires flashing Mendel Linux to the board and then accessing the board shell terminal once you. So pretty much is it's going to be kind of like the same process. All right, you flash some version of Linux onto the board, and then the board is connected, and now you can either remote or SSH into the board and use it to build any stuff you want to do. It's technically the same thing for most of this, um, this kind of boards. Okay, let's see. So and the flashing, I knew it. We're also going to need um, an SD card. Thankfully, I always have my SD card pouch on the table, so I have a lot of SD cards in there we can use, format them and use. We're going to see how that's done. Install MDT. Okay, technically, like I said, today's session is just to get it started, connect it, and do stuff. All right, so let's get started. So we have the board. So the setup requires flashing. So this is where I'm looking at for the sakes of my viewers. This is the section that I'm reading right now here. So as you can see, it's saying that the Corel Dev Board is a single. We know that from the package. The setup requires flashing the Mendel Linux to the board and then accessing the board shell. So pretty much that's it, right? But first of all, let's go and look at the data sheet. As you know, anytime we get a new board, we want to see the data sheet, understand what the board, the capabilities of the board, what it has, and then we can, yeah. So pretty much has got an Edge TPU system on module. It's running an MPX 8 megabytes system on no SoC. Socket on chip quad core ARM Cortex A53 plus Cortex M41. Runs the Google Edge TPU ML accelerator compressor. Well, co-processor. Why did I see that? Cryptographic co-processor, Wi-Fi. Okay, it has Wi-Fi, Bluetooth. It has an 8 gigabit eMMC. Whoa, that's a lot. It has one of four. I'm not sure which one this is, but we'll probably check it whether it's 4 gig of RAM. And then USB connections. You have a Type C for power, another Type C for data, and then audio connections. Okay, we have video connections as well. Micro SD has a gigabit internet port, and then 40 pin. Okay, okay, cool, interesting. Ah, so I think if we did a get started here, it should take us the. Hey, Nana, welcome to the show. Longest time, long time. Hope you're doing great since you have deserted Ghana. Hope you're happy out there. Anyway, it's been a while. Let me know if you have any questions on the show or generally about IoT and tech. I would be glad to answer it. All right, so let's get. It says what? Warning. Use caution when handling the board. Avoid electrostatic discharges. Yeah, so if you're in the house and have a lot of rolling stuff, be mindful because the more you work on it, your body generates a lot of static, energy. And if you touch some of these boards, you might fry them. I don't have any here. I'm not sure I have anything. I hope I've not fried it. So let's get into it. So it says note Do not, I think I should zoom in here. Yeah, since we're working from this side, so it's much bigger. Awesome. So we are accommodating to so we are accommodating with the people that might have some viewing challenges. So do not power the board or connect any cables until instructed to do so. Correct. You need to always follow protocol when you're going to do some of these connections. Before you begin, collect the following hardware. We need a host computer running Linux recommended, Mac or Windows 10. I'm running Windows, I'm fine. I have Python installed, I'm fine. I have a micro SD. So, like I mentioned, I need to just find if I have, no, this 128, I don't need 128. Let's see, let's see, let's see. No, I don't need 128. Now that's a challenge to see if I can find, no, 32. Did they say the size? At least 8. They're saying at least what, 8 gigabits? I have 16. Is there something on this one? Well, we will see. At least 8 means it can take more than 8. So let's see. Pa, pa, pam. Oh, okay, I have another 16 here. I just need to be sure that, I have, let's see, S5. No, this is not it. So all I'm trying to do now is I'm trying to get one of the SD cards. Yeah, 16. Okay, I have another 16 here. So I have 316 gigs, which should be fine. Well, there's another 8 gig. Well, I think it should be fine now. Yeah, the rest are all high capacity. How do you call it? Yeah. All right. So we'll check whichever of the cards. Um, I have one here. Let me actually check this out to see whatever is on it. If there's anything, I will just format that. So let's see. Oh, I think this is FS event, build data, trashes, readme, recovery. I want to believe this is something for insert an SD card into the size platform instructions. Yeah, I think yeah. So you know what? I'll just go ahead and format this. I will just wipe the label. Hold on. Does it say 1 gig? No. Cancel. This cannot be right. Let's see. Oh, okay. It's actually more than that. So okay. All right. So we have that, and then it says a USB Type C power supply 2.35, such as a phone charger. We have that. One USB-C. Oh, hold on. Such as, and then one USB-C to USB-A cable to connect your computer. Okay, so we have, I know we have, so currently we have a USB Type C right here. Let's just be mindful of this. Where is that? Where is that? There you go. Yeah. So we have a USB Type C that we have a Wi-Fi connection. So we have a USB Type C here, and it's saying USB Type C to A to connect your computer. Well, what if I connected this to the computer? Shouldn't this give us power? And this is just my assertion. Anyways, yeah, we pretty much have. I think we have both here, so we should be fine. All right. So we have all that. Note, although you can connect a keyboard and monitor to the board, we don't recommend it because the system is not designed to operate as a desktop environment. So that's a good one there. So in as much as you can connect a keyboard and a mouse to it, they rather prefer you use SSH or serial connections to it. So that's fine. Other Windows requirements for compatibility with our command line and shell script. Yeah, I think I already have Git for Windows. However, okay, so that's fine. So let's start with the first part. The first part is the dev board's factory settings do not include any systems images. Okay, it includes only a U-boot bootloader, so you need to flash the board with Mendel Linux. So which means we'll have to download and run Mendel Linux. To simplify the flashing process, we created a runtime system that runs on a micro SD card and then flashes the board. Okay. So it's saying that unlike other boards like Pi, does not run on the micro. We only use the micros to install the operating system on the built-in factory. Okay, okay. You remove the micros at the end of the process. If you don't have a micros, you can instead manually flash the board over USB. Huh. Manually flash the board over USB. This is interesting. Okay. This procedure is intended for new boards only. If you already installed Mendo, this details this delete all system and user data. If you want to keep your user data, it's okay, we don't need it. It's just for a new board. Okay, so to flash your board using the micro SD card, follow the steps. So that's the micro SD steps, and then it says that option 2, no, optionally, if you like to see the bootloader logs, well, no, we don't want to see this. I want to see whether there is the, okay, while the board boots up, you can install MDT on your host machine. Okay, let's go ahead. Let's start from here. Let's just go with, yeah, so this is what I was hoping. Let's see. Flashing to the board. Oh, okay. Okay. You should install. We have that installed. However, as a get. Okay. Open run can make Python accessible. All right. I think we already have Git Bash. It says that Git for Windows. Okay. All right, let's do it. So here it's saying that on Windows, it says for compatibility with our command line instructions and the shell script in our example code, we recommend using git bash. All right, so I have git for Windows. Um, Git bash terminal on Windows, which is included with git for Windows, so you should install it now. So I think let me run this my terminal as administrator. All right, I think I already have git bash. So I would open this, and then here I should look for, okay, so git bash is not loaded here in my, but I can add it to it. That's like a topic for another day. But so let's go and look for, let's go here and do git, where is that, where is that? Okay, so I think this is it, git cmd. Let's see, let me run this as an administrator and see. I believe that should be it. Okay. Okay. So let's see. Let me try ls and see if it not so. So dir. So this is not it. Okay. Let's see. As for Git for Windows, the Git Bash terminal cannot directly access Python. So after you install Git Bash, open it and run the following. Okay. So we have Git for Windows. So let's do this. Let's go ahead and do Git Bash. Yeah, there it is. Look at that. I said I knew I had it. So let's run this as an administrator. And yep, this is it. There you go. Yeah. So how, anyway, we could have also done that with the Windows Linux subsystem. We could have also done that with it. So not just having to do git bash. But I'm trying to go with the recommended part in it. So um, let me bring this here. Actually, let me bring this to the side here. Yep, there you go. Come on. We're trying to do this. I'm trying to get it to the side. There you go. Yep. And then we'll put this to the right hand side. So I think you see what I was trying to do there. Yeah. So we have the git bash here on the left, and then we have the instructions on the right. So here it's asking us that so let's do this. I'm sure I could have just copied it, right? Pa, 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 pa. Alias, we are setting an alias for Python. I think I already have Python 3 installed. right, right. So the alias for this should be winpt, unless of course my Python directory, I have Python 3 .exe. So this is the first one, this is the second one, and let's see this. Yeah. Okay. So, oh, we needed to pipe that to. So let's do this. Sorry, let's pipe that to root profile. Yes, underscore profile. Let's see. Yeah, 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 yeah. There you go. So just to make sure we have this piped into the dot bash underscore profile, and then all right. And now let's check this out. Let's see source. There you go. Bash underscore profile. Okay. So pretty much that's done. The next thing for us to do is setting to include. Okay, so we need to flash that. To simplify the flashing, okay, so they already have that. If you don't have a micro SD, you can. So we have a micro SD, so we'll go with the micro SD approach. And it's going to delete everything we agree. So using card, so download and unzip this. So um, that's what I mentioned. That it pretty much follows the same process or routine as all the other regular stuff. So let's put this on the desktop for now. Well, it's not that huge. We should have it done. So once that is done, it says we should unzip it, and that unzip file contains flashcard image, and then we need to use the programs. I already have HR. Okay, don't worry. Well, let's again. We're trying to follow the instructions they've given us. So let's go with their tooling and everything just to set it up, and then we can test that out. Okay. And if at this point, if you have any questions, feel free to um, drop it in a comment section and I would answer that. So let's see. Ba, 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 Okay, so I want to believe so that is done. And yeah, I think I already have HR. I do have it. I know I have HR ATCH. Let's see. I know I have it. I know I have it. There you go. I told you guys that I have it. I can't be setting up IoT dev devices and not have it. All right. So let's run this as well. So let's run this um, also on. There you go. So we have the two. So now the image has been downloaded, right? What is meant? Okay, yeah. I pretty much don't need this information. We have the tool already. So let's go through the process. For now, we'll just go ahead to minimize this, which is already open. Um, where is that? We put this on the desktop. Where is that? Where is that? Okay, so enterprise eagle flash. Was that how we saved it? Let's. Okay, yeah, that's it. Yeah, it's enterprise eagle flash. That's how we saved it. So that's fine. Okay, so it says that we should. Let's close this. We don't need this. So the zip contains a file name. There you go. So we have our HR open here. We already have the SD card connected also to my computer right here. I'm going to minimize that for now. So let's go ahead and unzip this. So show more option, extract it to this location. I mean, I'm going to extract it to the desktop, the same location so I can use the HR to, move the image onto it. So this how it's going to happen. We're going to burn the image onto it, and I'm sure we're going to boot the board with it. And then I'm sure they have some sample examples we can run to do that. And after that, I'll try to connect it to my system so we can see how the UI looks like, even if there has anything. Else, we'll have to use Visual Studio. Once we connect and create the SSH account, we use Visual Studio to remotely SSH into it and build anything we want to build. Okay, so that seems like it's done. Takes 5 minutes depending on the speed of, yeah, we have done that. While the card is being flashed, make sure your dev board is completely unplugged and change the boot mode switches to boot from SD. So you have to change on. Okay, so there's some dip switches we have to. Now, dip switches are a component that allow you to change, I would say, sequences or like um, ways of you can pretty much instruct your systems. If you're using a dip switch, let's say I can have an IoT setup. It's just a bunch of ones and zeros or on and off, on and off to determine setting pattern. So if I don't want to, let's say, have to I'm trying to look for a very simple example to explain what dip switches look like. So I can pretty much alter the effect of my application using a dip switch to change. Let's say if I turn a few of the switches on and others off, it might signal a different meaning for the board to do different things, rather than to programmatically upload files into it. All right. So I can say that the program on chip on my board, if the first dip switch is on and the rest are off, it means change states to something. I mean, that's kind of like a very simple explanation to that. All right, so let's do that. Let's go ahead and try to etch it onto the SD card. So all you have to do here is flash from file, right? So I'm going to click on from file, and then let's go to our desktop, which is where we have, so I think it's enterprise. Yeah, there you go. And let's go here, and that's the image flashcard here. So I open it, and I'm going to flash it onto the SD. It's already detected the SD in my reader, so I'm going to do the flash. And at some point, yeah, so you see Elena replay is asking some info. Yeah, we inserted the card, so it should be in there. So I think it's flashing, right? Yeah, it's flashing, so we can see that. um, let's see, ETA 2 minutes 16 seconds, so it's flashing. All right, okay, so whilst that is happening, whilst the flashing is happening, let's I'm gonna I'm gonna pick this up. The dip switches, you can see that it's quite so tiny. Let me switch to the bench so you see it. So it's right here. I don't know how I'm gonna focus for you to see this, but you see there's one, two, three, four. So you can see on and then on dip. So you see that. So it means if you push it up, that is going to be on. I need to get one of these. How do you call it? One of these microscopic cameras for viewing. Um, I need to get one. I need to get one because that makes my life easy. So I can zoom into some of these components and show this. Don't worry, 2022 will get some. So this is it. I think I should have something that should allow me to pretty much uh, tweak it. So let's see. I'm trying to pull out my set that I can use. There you go. I need you. I need you now. So all I did was to go for my tweezer set. Um, yeah, I think I could do with this one. This one is quite small. All right. So if you if we go back to our screen, and I'm going to, if we come here, I'm trying to zoom in here for us to see. Okay, so this, you need to format the disk before use. Do you want to format it? Yes. Uh, mm, so it's okay. I'll just assume I didn't see this because I know it's being etched onto the card right now. So yeah, there you go. Yeah, I think it's done. Yeah, so right now, if we go to we can see that this is done. And the reason why I was getting another message, but right now we can see that um, it's done. And let me gladly just take it out. So the flashing is done. All right, so we can close this. Now it's asking us to set the dip switches in this. All right, and then from what we've seen, if I position it the way it is, it means that I need to move the first one on. So everything should be on with the exception of the second one. So 1, 3, and 4 should be on, and then 2 should be off. All right. So let's go to the bench and let's try to do that right now. So uh, bear with me. So it says one is on, 2 is off. So 1 I can see is already on, 2 is off. So I just need to switch 3 and 4 on to leave 2 off. So I have just done that. If you can see closely, you can see that now I pushed 1 up, 3 up, and 4 up. 1, 3, and 4. Yeah, so I pushed those up. So we pretty much put it in that mode. Now, what's the next thing we have to do? So the next thing now, which we've put it in that mode. So boot, yeah, we've done that. So once the card, now it says once the card is flashed safely, what do we do? What do we do? What do we do? What do we do? Once the card is flashed safely, remove from the computer and insert into the dev board. Okay, the card the card spin face towards the board. Okay, so pretty much, let's go to the bench. So here it is. So yeah, if you have it this way, right? If you have it this way, it's asking that we put it in that way, right? So there you go. There you go. So now I have the card in there. So the card is in. Um, the board should not power. Yes, I've not powered it. So all we've done is just flash and put it on. Right? Awesome. Now what next? Optional if you like to see bootloader logs while board is being flashed, either connect a monitor. Okay, so that's what I want to do. So because of our previous, so I have here. So I want to connect an HDMI to it. Yep. I hope this doesn't freak out on me. So what I've done is just connect an HDMI cable so we can see. Um, okay, port on okay. All right. Then now power by using a 2 to 3 amp power cable to USB. So cable to USB label power. All right. The board. Do not attempt to power the board by connecting to your computer. Okay. So yeah. So this white cable here is a USB Type C that gives me power, 2 to 3 amps. All right. So if we turn this and look on the board, I see that this one here, the second one is the power. So I'll put it even if you're not sure, we always have the schematics to help us go with it. So if you look at it carefully, if you're holding the board this way, just like this, as you can see, the USB power is the second one, right? So there you go, and it's actually even written here. If you look closely on this side, you should see power, which is for this one, and then this one is for data. So I'm going to connect this to it, and yep, you can see that. Let's do this. Sorry, guys. Bring this here. Yep. So now, okay, I think I should do this. I should just lift it up and put it on top of this. Yeah, this works. So now you should see the red lights. I see. So yep, pretty much there's power in it per what we are seeing. Um, well, I don't know what happened, but this has gone off. But anyway, I see the red light. Can I kindly uh, see your SD card? Yes. So the SD card, I just put it in there right here, down here. It's a micro SD card. I don't know if you can see that, but this is it. It's a micro SD card right here. All right. And I mean, for the sakes of people, this is how the micro SD cards look like. All right. This. Let me bring my finger here so we can. So this is a micro SD card. So Prime IoT, I don't know if this answers, but this is the micro SD card, and I have an adapter, and this is the adapter I use. So the adapter here, I put it in the adapter this way, and then I put this into my computer, and then I can read and write from. That's how I did it, and I flashed it. All right. So yeah, that's how the micro look like. I hope that helped. Unless of course unless of course you're asking for something specific, let me know so I can address that. All right. So let's actually do this four-way thing here. Right. Nothing is showing yet, so pretty much. Okay. So it says that on the top left, which you have the instructions. Um, When the board boots up, it loads the SD and then begins flashing the board's EMC. It should finish in 5 to 10 minutes, depending on the speed of it. If you will know it's done when the board shuts down and the red light turns off. So it's not okay. So let me see if we're getting anything from this. All right. The red light is not off yet. Okay, I'll leave this in here. I'm trying to see if I can get. Let's go to the bench. I was just trying to figure out if I could get this, for us to see what's happening on. I would really love to, you know, see that. So let's see. There you go. Yeah, and the funny thing is sometimes, when you connect some of these things, they they ask you to, reconnect or reconfigure. But I think this is fine. Let's try again to see if we can see it on the screen. No. And yeah, just give me a moment. Let me see if we can pretty much change this. I want us to see possibly, let's see. Let me try this again. Activate. There you go. Yep, yep, yep. All right. So I hope you saw that. Yeah, so there you go. So what you're seeing now, is actually what's happening on the board. Let me go to the four-way view. So, come on, 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 come on. Oh, let me add this. Let me add this. Let me add this. It's an existing one, and I'm gonna bring it here. Yep, there you go. The power of my OBS. Okay, so what you're seeing on the bottom left, right, is actually what's happening to the board right now. So the board is being flashed. The firmware is being flashed on it. And like the instruction said, is saying on the top one right here, it says that, let's see, we've connected to power. It says that, so it says when the boot, so it says it says when the board sets up, um, it loads the SD card image and begins flashing the board's eMMC. It should finish in 5 to 10 minutes depending on the speed for your micro SD card. So you know if it's done when the board shuts down and the red LED turns off. So currently the red LED is on. I can see the red LED on right here. And if you look in the bottom left, you can see the screen um, of the, whatever output is coming from the board. So it says that when the red LED turns off, unplug the power, and I'm reading this from the top left. So when the LED turns off, unplug the power and remove the micro SD card. Change the boot model switches back Okay, so on, off, off, off. Interesting. So pretty much what we are doing right now is it's using the SD card to flash the image onto the the system. And once that is done, we don't technically need the SD card for it to be booting off of. It's going to be booting from its own bootloader. So that's why it's usually, so like I was explaining, the diff switches was used to change the boot order. So if you're writing a program and you're writing, let's say, a conditional statement, say if um, bootloader is 1, all right, use memory card. If bootloader is 2, use onboard. So you can use a diff switch to embed such logic into your devices. That's what diff switches are for. So it says that between 5 to 10 minutes we should be able to um, see that it's done. um, let's go see quickly. I wish I could see this a bit bigger, but it's quite small. Hold on. I'm seeing I'm rather seeing an error. It says IO error, sector something 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 dev blah 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 blah. Okay, you know what? Let's do this. Let me. I want to believe that it's having an issue with the memory card. All right, so I'm going to use another memory card. Sorry, another SD card. There's another 16 gig I have. Unless, of course, it's not happy with the 16 gig, it wants like just an 8 gig. So let me quickly see if I can find one of the 8 gigs I probably have somewhere. Oh, this is 64 gigs. No. Crash stamps. Okay, you know what? I'm going to use this. I think I use this to flash onto. So I'm going to go ahead. This is it H? H. Interesting. Well, anyway, so let's try the. We're going to try the. I'm going to try the 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 writing of the file again because I still see it's just repeating. It says IO error. All right, so let's do this. Let's do this again. So let's minimize this. Let's open. We had. Yep. Let's open HR again, and this should it should flash it, and then we'll try to do the same thing again. All right, so once it loads, so again, in order to do this, I'm going to take the power out. Okay, I'm going to flip it over, and we will replace it with a new. Let's go ahead and okay, let me format the disk. It's a quick format. I won't give it any label. Start, yeah, clear everything on it. Okay, that is complete. Okay, so pretty much that's formatted. Main OS data age. Oh, pretty much I don't really care about. Let's see if I can. So DE. Let's see if we can format this as well. Let's see this. So I'm just preparing. What I'm doing now is I want to prepare another, pretty much another SD card for us to make use of. So let's come here. Sorry, so this is clean. Let's see if we can format this. Okay, that's formatted. And okay, there you go. There's another one here. Wow, and data. Let's just format it. Okay. Ah, interesting. Okay, so that's also done. All right, so let's do this. So it's seeing the SD card in it, and I just want to use that SD card, and this is the image I want to write, and then I'll just flash. So this is it. So I open HR again. I selected the image, so it's picked the SD card, and then I'm going to flash. All right. So my theory is that the how do you call it? Let's see. Let's do this. So it's flashing. As of now, I haven't got any message like I did for the first one that was complaining. Okay. So that is it. Nah, I don't need this. It's flashing, 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 flashing. Okay. So ETA for so less than 3 minutes. Yeah. Well, I know we're a bit behind time. I don't want to do a part two of this because let's see how many Tuesdays. I don't want us to have a part two of this event. Well, we have like two more. We have two more sessions before the year end, but at least we want us to set this up and use it. Let's see. Let's see if we have like. Let's go a little. Probably the next 10 minutes. Um, see if we can, get this done, and then we can do some. But in the meantime, if you have any questions, please throw them my way. Um, let me try to answer them to the best of my knowledge or ability or understanding, and then yeah, I'll take it from. But in the meantime, we're just waiting for it. So Emmanuel, Prime IoT. I hope that I'm ensuring the SD card should answer your question, unless of course you have any specific questions. Now, one thing I want to ask of you whilst this happening is that again, please subscribe to the channel. I want to grow the channel. I want to get 1K, at least 1K before the year ends. So please subscribe to the channel and grow it. Now, another thing I would also ask from you is that put in the comment section or reach out to me on any of my social media handles, and let me know what you think. All right, let me know what you think with respect to what project you want us to be building. I made mention that we'll be doing Let's Experiment. This is going to be like a different show than this. That's going to be like building stuff, live stream on how I'm building stuff, or live stream on what's printing in the 3D printer back there. So what I plan to do is, for those that support my channel and those that are interested in helping out, there'll be a special link for you to have 24 hours, live access to whatever is happening, to whatever is printing in there, and also you get to see firsthand what's happening before it comes on air as well. So let me know if that's of interest to you. Couple of things we've been working on and we've not finished is, as you can see, there's a drone up there, right there. That drone, we were supposed to have set it up with our own flight, the flight system. We haven't gotten the chance to do that. So, oops, we have an issue. It says flash failed. Let's see. It said, let's see, let's flash another. Let's try this. Select a target. Yeah, this is what we want to do with selecting it, and then we want to flash. Yeah, so pretty much Let's Experiment is going to be um, a bigger, more, more inclusive kind of like channel or content. So let me know if that's of interest. And like I said, if you want us to build anything, work on anything, share it with me in the comment section, and then we'll work on it. So absolutely. And another thing I'm also trying to do is that I want to have the unboxing separately on its own like playlist. So I'll just unbox for you to see, pretty much what is in it, test it out, do all that. But then using them will be on your respective shows. So let me know what you think of that, because the content I create is supposed to help us all, learn and understand stuff. So if you have any, questions pertaining to um, all I do on the streams, the tools I use, the softwares, the technology, and all that, hey, let me know. And I'll be sure to answer them, or give you some steps in the direction. If you're new to IoT and you're just getting started, feel free to ping me, send me a message. I'll help you get started. Dev kits, what to do, what to learn. Yeah, ping me and I can help you do that as well. So where are we? Let's go back here. Where are we? Where are we? Mars rover prototype. Mars rover prototype. What's the name of? There's a Ghanaian physicist or scientist who was working on that. I mean, again, it's not that it's far-fetched. I mean, if you look at um, chassis like this, all right, like this one. Let me actually go here. If you look like, chassis like this one, all right, what's happening? Our flash is failing. Okay, so I'm going to try. Let's try this again. I'm going to try the third. I'm going to try the third SD card, and then we'll see. There you go. Let's open that up. I think maybe it's the, you know, ah, okay, good. This is just one. Thank God. This is just one. There you go. So let's try this. Select the target. There you go. Select. The image is there. Let's try the flash. Okay, so you might Ma- Daniel Mars River prototype. Yes, that can be built. Like I was saying, you have like, well, you have chances like this, but again, like I mentioned, if you have to build any specific chances for the Mars Rover project, we can do that because we can pretty much CNC or laser cut any of the chances. And I think I have a lot of motors and um, actuators and servos that we can build. Okay, so for those in favor of the Mars Rover prototype, please let me know in the comment description, in the comment section of this video, and then the highest vote. Okay, so we have Mars Rover Prototype 1. At least we need to get, maybe two more options of what to build. So that will be exclusive on Let's Experiment, and then except of it will come on the IoT show. As saying, how did we build this section of the rover? We can show that on IoT or the Mystified Tech on that, and then maybe how we printed an enclosure or something for the rover will come on the 3D printing show. So Mars rover prototype, one project. I'll capture that, Daniel. I'll capture that. Who else wants to volunteer? Another project. Let me actually make the note of that. Let's see. Mars rover prototype. So that means, so we can look at the processes, which means we have to look at schematics, what it has to do there, all that. We can look at that as well. But that's just one. I would really be happy if we can close this up before the year starts, so we know that in terms of project we are building, this is a selected project we are building, maybe for the first month or the first quarter or something like that. So if you are in support of that's Daniel's suggestion of Mars rover, please either maybe thumbs up or something. But we need to get a second or third option of what we need to build. I might probably have to do an official poll on Twitter or any of the platforms so that we can see which of the options are picking up. But if you think you like the idea of a Mars rover prototype, hey, why not? Let me know, +1 or thumbs up or something if you are on the stream right now, or if later on you watch this on demand on YouTube. And yes, and that's the other thing. A lot of people think that once I stream live, that's the end of it. No, it's not the end of it. Once I stream live, it goes onto YouTube, on demand. So you can go back to my channel and watch it again. So don't feel that because you didn't join the live stream, you can watch. It's always available for you to watch after the stream. Okay, so please, 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 don't hesitate. And again, if make sure you subscribe so that anytime I post anything, you're gonna get it. Let's get to 1,000 people. So Mars Rover prototype. Who else? Who else? Who else? Who else? Prime IoT and the rest. Who else? Who else has any suggestions? Yeah, I believe we can do that. Let's see. Let's go back to my 4 views split. You're not seeing anything in the bottom left because the board is off at the moment. So as soon as we bring the board back on, we should see what's happening in there. And yes, so this is done. Um, that's awesome. So it looks like, how do you call it? It looks like it flashed. It flashed. So awesome, 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 awesome. Okay. Okay, okay, let's do that. So this is what I'm going to do. So now let's take it out. So I'm going to close this. And what I'll do is that this time around, I want to properly eject it. I don't want a situation where it failed on us, so I properly ejected it. And so this is the new one. Let's go to the bench and let's take out this one. And then let's put this one in. There, there you go. And let's get this ready. So let's keep our fingers crossed again. Let's power this. And if you look at the bottom left, I think once the power comes in, we should see um, something happening. All right, there you go, there you go. Okay, so this looks, yes, this one looks more like it. I don't think I see anything error related. So realize that this one stuck around for a while. Um, let's actually go see if we can get in there big enough to see what's happening. So okay, so the flash has started. So if you look closely on the, and unfortunately I can't control the view from this one, but this what's in, it's in there. If you look, it says flash start writing image files, right? So yeah, so we're going to keep an eye on the red light on that side to see once it's done according to the text, it should pa, 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 pa. Let's see. Let's see. Okay. Pa, 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 pa. So yeah, yeah, it's running. So at least I don't see any errors. I want to see if we can have seven. I'm trying to see if there is kind of like an image writing. I can see writing partition table flash start. Yeah, so pretty much, yeah, it's working. Um, Daniel, since you suggested the Mars rover, what role would you want to play in that development? What do you say? What do you say? So, Daniel, I'm interested to know what role you want to play, considering the fact that you suggested it. Even though we're still waiting for like two people, so assuming that we're like, hey, let's do it. What role would you like to play? Let me know in chat, or you can hit me up um, any of my social channels. All right. So let's see. I know we are about 14 minutes, actually 15 minutes over time. Um, at least I want the image to be flashed on it, and we can know that the image has been flashed successfully, and then we can do a part two of this next week. Yes, I think something happened. Something happened. Even though the red light is still on, I think it sends a message. Let's see. Okay, so it's writing the different file systems. Yeah, yeah, so yeah, let's hang out here for a bit. Let's hang out here for a bit whilst the system tries to set up. At least before we end today's stream, we should make sure that our board is set up with an image, and then next week we can maybe try out one of the samples and build something on it, and then we'll move on to the next thing. But we're still waiting for two more suggestions for the project for to start working on next year, couple of weeks. Where the first one is Mars rover prototype. This guy is just, Daniel is just going to make me start looking out for this schematics and all the crazy stuff. And maybe we'll see what concept you want to build and stuff like that. We can test that out. Yep. And hey, like I mentioned, if you're interested in IoT, whether you want to learn it as an individual, as institution, as a group, um, please keep out, watch out for boot camps on IoT, on 3D printing, on robotics, and then drones coming up pretty much in the very early stages of next year. And then also Tech on Wheels is going to start next year, where we're going to take technology to the deprived people or the rural areas of the country. If you're interested in helping with tech on, tech on wheels or any of the voluntary social good projects, please reach out to me and let me know. I'll add you to it. If you're a school and you want to add that to your project or something, reach out to me and we can make that happen. I can help with the design and programming. Awesome. Okay, so what we're going to do is that Daniel, reach out to me after the show, maybe on my Twitter or something, or email. Uh, send me, um, send me something, and let's see how we can get together to do that. Yeah, um, yeah. With the design, we can pretty much figure it out. We can pretty much figure out what design concepts to use and all that. So hey, that sounds interesting. All right, let's see what this is showing. Writing, well, it's still writing the file system. Anyway, it said it was good. It can take between 10 to 15 minutes. Let's see. Let's go back to the to this up here. So if you look closely from what it said, okay. So I think we have something to do whilst the board. So it says it can take between 5 to 10 minutes, depending on the speed of the micro SD card. Well, once that's still working, here it's what it says. It says that booting up the first time. Now, while the board boots up, you can install MDT on your local host. So it says MDT is a command line tool that helps you interact with the dev board. For example, MDT can list connected devices. So if it's going to be SSH, I think we can even use Visual Studio Code to do that. But in any which ways, let's see. Let's see. Okay. Uh, all right. So let's do this. So you remember it made us actually set it up in our Git Bash. So let's open our Git Bash. Let's put this here. Okay. So let's try this. So let's do Python 3 and then let's do pip install. Pa, pa, pa. Mendel development 2. Oh, hmm. This is interesting. So let's see. I do have Python installed. Oh, it's going to download it. But I do have Python installed. Why do I feel like I can use a Windows subsystem to do this instead of going off of their Python? Because Python is already installed. If I should open command prompt now and type Python, um, that should pretty much look at that. Oh, good command prompt Python. So this is what I so this is probably going to install this Python into my. Okay, you know what? I'm going to get it. I'm just going to get it. I don't know why, but here so here's the case. If I did this, all right. If I went to CMD, right, and then I typed it, I think I'm using Anaconda. I set this up to use Anaconda, so that should be okay. It's brought me back here. So anyway, well, let me just install and get the Python ready. All right. So if we go back to the bench, now you can see that the light is off and there's nothing showing in there. So that tells us that at this point our board is fully, set up. So because it's fully set up, if you remember the steps we were asked to, to go through, let's go back here and bring this up. We are supposed to change it back because right now we are on off on. If you look closely, on, off, on, on. But right now, we are going to move it to on, everything off. All right. So um, let me take. So what is it? Turns of. Okay. So let's see. It says that when the red light turns off, unplug and remove the micro SD card. So let's go ahead and do this. So unplug this, remove the mic, and that's it. I don't think we will not need this micro SD again to set it up. So pretty much its work is technically done. All right, and then uh, where is our tweezers here? And then we need to set everything back to on, off, off, off. So if we go back here, and once we do this, we will end the stream for today, and then so right now we are on, and then we need to shift this off and shift this off. So now that should be on, off, off, off. So there you go. So right now we've changed this cable is in the way. All right, so we've changed it to on, off, off, off. Awesome. Yep. So now that is done. Uh, okay. So at this point, it says that if we should connect this again, let's go back to our 3 view. Actually, yeah, and it boots up now. It's going to boot, um, and there you go. So now, if I go here, huge, you're seeing that now it's booting. It's a complete Linux OS booting, and this is booting without, this is booting without it's booting without the SD card because we've already put the image on the SD card, right? So, for spaces, whilst this is running, um, I would wait for to finish installing the Python on the machine as well, and then yeah, we can actually have some fun. So let's close this, and I'll try as much as possible to figure out my default Python settings. I know I have Python 3.0 because when I use Visual Studio Code, I get Python 3. So pretty much, yeah. Okay, so um, at this point, um, I guess we can safely, say that we've been able to set up the board. So we're going to end today's stream here. Thank you very much for making a date with me on next week's episode. Is going to be part 2 of this. So we're going to continue to set it up and then finish and probably run. Right now that we know the OS is on, we'll go to the next steps. If this seems like something of interest to you, another IoT project, um, kindly subscribe to the channel, hit me up with any questions, and then let's make this a fun show. Until then, stay safe, be good, think positive, and I'll connect with you again next week for another trailing episode. With that said, I am out.